So just like with the Lentic form, the Lentic form has a section on vegetation, and we find the similar pattern of questions. We are yet to rewrite this one, so it's in this case age class distribution first and then composition. Then the species present, what are they indicating the maintenance of riparian soil moisture characteristics? Do we have vegetation that is comprised of those plants or plant communities with the root masses capable of withstanding whatever the energy event is for the system, the energy that can put the system at risk, be that wave action or overland flow events, storm events, etc., snowmelt. And next one is the vigor question, same question. And then do we have enough of the vegetation present to protect the shoreline and to dissipate energy during the events, either the wind or wave or overland flow events? We do have a couple of new ones here, though. There is the question of frost or abnormal hydrologic heaving. John just talked a little bit about that, and we'll have a whole question focused on that. And another question focused on favorable microsite conditions, woody debris, water temperature, et cetera, maintained by adjacent site characteristics. Usually those adjacent site characteristics are something like a large, perhaps old-growth forest, shading a wetland area. So anyway, that's the sequence of questions. So let's step through them on a one-by-one basis. Question 8, there is a diverse age class distribution of riparian wetland vegetation. Purpose to determine if sufficient age classes are present to indicate recruitment is occurring. Not necessarily all age classes, usually just 2 are sufficient, especially the established seedlings and the middle age are the more important ones because that indicates the continuity of reproduction. So young shrubs, middle-aged shrubs, those are particularly easy to detect. It's a bit harder with herbaceous vegetation. With a practiced eye, you can see that you have some patches that are brand new patches and others where the stabilizing species are expanding outward and have established more of a patch. Certainly if you have an area where you do not have the reproduction and you don't have a diverse age class, then the answer would be no. And some areas are grazed in such a way that you just understand that things are not thriving and reproducing there well. Question 9, there is a diverse composition of riparian wetland vegetation for maintenance and recovery. So in this photograph we see both sedges and bulrushes, cattails. On the herbaceous, we also see alders and red osier dogwood and some trees, and so we have quite a diversity. What you're looking for is the couple of species in the herbaceous group and in the woody group. If both the herbaceous and the woody are needed, it's whatever you have the potential for and whatever you have the need for in order to keep the system physically functioning. Question 10, species present indicate the maintenance of riparian wetland soil moisture characteristics. Usually those plants will indicate the presence of a shallow water table or not. It does not ask if there's enough plants, only if the plants there by their location indicate that we're maintaining that wetland set of moisture characteristics or not. So to do that, we use the wetland indicator rating of the various species, and the two groups that are particularly interesting to us are the obligate wetland plants. Those are the ones that always, virtually, more than 99% of the time occur in wetlands, and the facultative wetland ones that are usually in wetlands, although they could occur outside of wetlands. Facultative wet is particularly important. Facultative can go sort of either way. Facultative upland can occur in wetlands, but usually not, and obligate uplands almost never occur in wetlands, at least not if they're maintaining their wetland characteristics. So there you see some examples. We have Nebraska sedge going from top to bottom on the wetland rating. Juncus arcticus, also called Juncus balticus or Baltic rush. Kentucky bluegrass is that facultative right in the middle. Woods rose, facultative up, and of course cheatgrass is just an example of the upland species, obligate upland. Question 11. Vegetation is composed of those plants or plant communities that have root masses capable of withstanding wind events, wave events, overland flows, storm events, snowmelt. So do we have the right plants, the right plant communities, and are they in the right place where that energy is happening? On the shorelines where the wave events would happen, open water areas, soil surface and seeps and wet meadows that have the right plant communities. The place where I would look in a lot of our upland meadows that might be particularly important for sage grouse is, do we have the right plant communities on the nick zones or the steep places that are where the water flow in that meadow often happens at the surface, and where that could turn into a head cut if we don't have the right plant communities. For a small pond, I might look to see if we've got the right plant communities in the place where the water would flow into that pond to keep it from filling up with sediment. So it's the plant community and it's the stabilizers, and are they in the right place? Still not the adequacy question at first, but the question of whether we have the plant communities. And then, are they vigorous? A low vigor can be illustrated by sort of a poor size. It just never gets very big because it keeps getting beaten down, or it doesn't have the opportunity to grow very well. Might have some tissue degeneration, some off color, some wilting, perhaps a high level of attack by insects. Sometimes you can see vigor. It's hard to measure. Question 13, adequate. Now we're at the adequate question. Riparian wetland vegetation cover to protect the shoreline, soil surface, and dissipate energy during those wave events and overland flows. And so we're, again, looking at the places where we need it, and we're asking the question of whether we have enough. And that's enough of the stabilizing species that do the work of holding the soil and preventing the erosion. Erosion being a really significant part of the risk for riparian areas if they don't have enough. So a sufficient amount of stabilizing vegetation. The soft stem and three square bulrush in this photograph are good stabilizing species, and we've got a large amount of coverage around this pond where the wave action would be, so that would be a yes. Here we've got some issues. You can see where the red circle is that we've got a breach in the dam. That is actually going to be covered by another issue, but that has allowed the water table to go down, and what we see is that stressed vegetation on the shore is not particularly encouraging. I think that other circle is around a salt block, and so if somebody is salting their cattle close to the stock tank, and that could be another reason why they're getting a concentration of animals. My sense in general for riparian grazing is that it's pretty similar to Lodic grazing, Lentic and Lodic. The big tool in the toolbox is recovery period, and so having a period of time when those plants can grow when they're not being grazed is hugely important. We'll talk more about grazing later. But salting in the riparian zone is an opportunity missed, at least. So this new question about frost or abnormal hydrologic heaving is not present. The purpose is to determine whether the frost or hydrologic heaving is at a normal or aggravated rate. So that really leads to the question of what is a normal rate? What is this process that we think of as frost or hydrologic heaving? And I think it's one that a lot of people have scratched their heads about. Paul Nyman is doing some research about this over in Colorado, and yet a lot of his research is still in the head-scratching sort of phase. Terry Booth has also done some research on it over in Wyoming. There clearly, from Terry's research, seems to be a relationship to the feet of large ungulates, and that's my sense as I have observed things in the Great Basin, that most of the time when we see these mounds, it was initially triggered by breaking the sod, punching the sod, pugging, and leaving high areas and low areas because of that breakthrough. Now, once you have the high area and an area around it surrounded by water, then you can have the ice crystal formation and the expansion of ice as it goes from water to ice, squeezing in on the neck, on the stem of the toadstool, if you will, pushing the soil up, and eventually maybe even causing these pedestals to tip over. But the real risk, as I see it, is the preferential flow paths, the altered flow paths that John talked about between the hummocks. If we've got bare area between the hummocks, that's an opportunity for water flow during a water flow event to flow over exposed bare soil. And since many of these systems are not very quick accumulators of soil, loss of soil is a big deal, loss of water table elevation is a big deal, and channel incision that can drain these wetlands is something that we clearly need to be careful about. So here's an example of one where it just looks to me, and from the history of places like this, I certainly have every reason to believe that this was triggered by livestock. It can eventually heal with an appropriate form of livestock management. What really needs to happen first is for those bare areas to get healed over. We also have this question 15, favorable microsite condition, woody material, water temperature, et cetera, is maintained by adjacent type characteristics. There's some sundews and that live on rotten logs, and the logs come from the surrounding forest. In this case, we have a wetland that was shaded by the surrounding forest, and absent the forest, it doesn't provide the shade or the logs for the sundews. Usually in Great Basin systems that I'm familiar with, this is an NA. I don't think we very often depend on adjacent microsite characteristics. When we do, we have rated this occasionally, but usually it's an NA. Here is one where we once had an aspen woodland around a meadow area. This meadow is clearly a different habitat than it once was. So you could note that by the absence of the forest that we have today, even though it's in a place where we once had forest. With that, I'll turn it back to John for geomorphology.